Hello everybody, this is the third installment in my series of calculus, and today it's going to be trig differentiation. So sine, cosine, tan, that kind of thing. So welcome back to the channel first of all. Let's just dive right in. So first we've covered what differentiation actually is. So the first principles, so f prime of x equals f of x plus h minus f of x all over h. So if you haven't seen my previous two videos, I would highly recommend you go see them, because this video probably won't make that much sense to you without it. So we know that this is what differentiation actually is. And sort of so we know this is what differentiation basically is. And we also know that if we want to differentiate a polynomial, so ax to the n minus 1, ax to the n, spoilers, we get an x to the n minus 1. However, what if we get something that is not in this power rule form? For example, sine x. Then what? So we have to go back to the first principles if we get something like sine x, which is what I'll prove to you today, what the sine x derivative actually is. So let's just plug it in. So the derivative of sine x equals the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Then we can use the sine addition formula to say that this equals limit as h approaches 0 of sine of x multiplied by cosine of h plus sine of h multiplied by cosine of x minus sine of x all over h. And this is equal to the limit as h approaches 0 of sine x cos x minus sine x plus sine h cos x all over h. Just move the sine x's together. Then we can take out a factor of sine x. So then this equals limit of h approaching 0 of sine x cos h minus 1 plus sine h multiplied by cos x over h. Then we can split this limit up into two separate limits. So then this equals the limit as h approaches 0 of sine x multiplied by cos h minus 1 all over h plus the limit of h approaching 0 of sine h cos x over h. And also, what we can do now is we can take the sine x, technical difficulties. Yeah. So we can take the sine x out of this limit because it doesn't include an element of the h, and it's just being multiplied to the rest of this fraction. So we're able to take it out as so. Cos h minus 1 over h plus, so we can do the same to the cos x here as well, plus cos x multiplied by limit as h approaches 0 of sine h over h. Now, if we think about it, as limit h approaches 0, what is cos h minus 1 over h? Now, we can do some tricky algebra here and some manipulation, but I don't really want to go too far into that, so I shall show you something instead. So this cos h minus 1 over h, as h approaches 0, what value does that give us? Well, I've plugged it here on Desmos, actually, and as we can see, it approaches 0. Now, I know it's not a rigorous proof, but just accept that because it's a little too complicated to explain. So this equals sine x multiplied by 0 plus cos x multiplied by, so what does the sine h over h show? Well, if we look at the graph of that, we can see that as it approaches 0, sine x over x gives us 1. So as h approaches 0, sine h over h is going to give us 1 as well, multiplied by 1. So then all we're left is cos x. Therefore, the derivative of sine x, equals cos x. And we can do the same for cos. And what we find, fascinatingly, is that sine is kind of a loop. Sine x will differentiate to give us cos x. Cos x will differentiate to give us minus sine x. Minus sine x will differentiate to give us minus cosine x. And then minus cosine x will differentiate to get us back to sine x. And this can go on forever and ever and ever. So it's quite interesting. So as a side note, now that we know sine and cos, we can also get tan, because you probably know from your trig formulae, tan x is just equal to sine x over cos x. So we can use something called the chain rule or the quotient rule, which we're going to do in future episodes. We can use that to find what the derivative of tan x actually is. And if you do that, we'll cover it later, but you can find that the derivative of tan x gives you something called sec squared x, which is the same as saying 1 over cos squared x. Okay. See you next time. Bye.